In the last few videos, we talked about functions, we defined them, and we talked about different properties of functions and notation for functions and things like that. Now we're going to start looking at specific functions, and in this video, we're going to look at linear functions. I'm sure you've all worked with linear functions before, or obviously, lines, root word of linear. There are different ways to write lines. We're going to look through all of them just to make sure we're clear on what's going on, and we're going to look at the different properties of lines. I am sure you've all seen this before because they start teaching it in like 7th grade now. But I just want to make sure we go through and understand everything. So, when we have a line, we'll say my line looks something like that. As far as it goes, there are different properties I care about. One of the main ones is what's called the slope of the line. The slope of the line is the rate of change of the line. When we talk about change in math, in this case, we're talking about how much it goes up or how much it goes down, or if it doesn't go up or down at all. That's the slope, which is really just a rate of change. But then there are a lot of ways to actually define that when we use it. Generally for slope, we use the letter m, and if you want, you can say delta y over delta x. That's that Greek letter delta that I mentioned in the last video. All that really means is change in y over change in x. And essentially that means if I want to know what the slope of that line is, I have to pick a couple of points on the line. Maybe I'll say this point right here, which I'll call x1, y1, and this point right here, which I'll call x2, y2. Then, in order to find the change in y over the change in x, the slope, I do the change in y, which is y2 minus y1, over the change in x, which is x2 minus x1. And that will tell me my slope. As far as it goes, however you choose to remember the slope is kind of up to you. Ultimately, you need to be able to find it. This is the actual mathematical formula to find it. So if nothing else, make sure you remember that. But suppose, like I said, this is my line and those are my points. And say this point is 1, 4, and this point is 5, 10. If I then want to find the slope, I just say the slope is the change in y, 10 minus 4, all over the change in x, 5 minus 1. 10 minus 4 is 6, 5 minus 1 is 4, and my slope is 6 over 4 or 3 over 2. All that, again, there are different ways to interpret this. Another way to interpret this 3 represents the change in y, which is how much the graph goes up, how much the line goes up. So I can also say that's the rise, how much it goes up. This is the change in the x's, which is horizontal. So I could say this is run. So another way of defining this slope is as the rise over the run. One way to interpret this is, given any point, say this one, to find another point on the line, I rise 3 and run 2. So I would go up 3 and over 2, and I would get this point. Then I would go up 3 over 2 and get that point. So again, there's an understanding of this as well as a knowledge of the formulas that kind of all goes together. But we want to mess around with this a little bit, again, to make sure we kind of fully grasp what's going on. So for the sake of argument, suppose I have another line, say this one. And we will just say the slope of this line is 2. If I then had a second line here, maybe this line right here, how would the slopes of those two lines relate? Well, if the slope is kind of how much the line is changing, and by changing we mean how much it's going up, then logically, if this line, the red one, has a slope of 2, the blue one is steeper, which means it's getting bigger faster, which means its rate of change should be greater. So maybe the slope of this would have to be bigger. We'll say it's 5. I'm just making those numbers up. But the point is, since the blue one is steeper than the red one, the blue one has to have a bigger slope. So then, suppose I had a third line. I have to get a third color. Suppose I had this line right here in green. What would the slope of that line be? Well, again, if we kind of compare slopes, the red one has a slope of 2. The green one is clearly flatter than the red one. If it's flatter, it's not changing as much, which means the slope has to be smaller. So maybe we'll say the slope of that one is 1. Can you ever have a line with a slope of 0? Well, if the slope is measuring the change, the less it changes, the smaller the slope gets. Is there a line that never has any change at all? Well, sure. If I just draw a horizontal line, we said change refers to change, rise over run, how steep it is. This is completely flat, so it will have a slope of 0. But then, if I go back to more graphs over here, when we read our lines left to right. So from a left to right perspective, all of these are going up. This one is not going up as quickly as this one, which is not going up as quickly as this one, but they're all going up, right, left to right. This one is not going up or down, it's flat. This one is going down. How should the slope of this one relate to these? Well, if you think about it again, when it's really steep, maybe the slope is 5. As it gets less steep, the slope goes down to 2. As it gets less steep, it goes down to 1. When it gets to horizontal, it's 0. If I keep on going, my numbers should decrease, which means slope here is maybe negative, something like -2. Which means when looking at our lines, if your line is going up left to right, you get a positive slope. If your line is going down left to right, you get a negative slope. So now, just to kind of make sure we're clear on all the properties here, suppose I have this line right here. And I say I have the point 1, 1, and I have the point 6, 6. I want to find the slope of that line. We read the line left to right, it's going up, I know then my slope should be positive. So to find the slope, I do y2 minus y1 over x2 minus x1, which will be 6 minus 1 over 6 minus 1, which is 5 over 5, which is 1, which is positive, which is what I thought I should get. But let's face it, inherent in that is me kind of just reading left to right because I read left to right. And I'm saying this is point 1 and that's point 2. But suppose I happen to read right to left. There are languages, Japanese, Farsi, other ones, that read right to left. They might say this is point 1 and that's point 2. Does that in any way change my slope if I do it backwards? Well, if we check it, the slope is y2 minus y1 all over x2 minus x1, which in this case would now be 1 minus 6 all over 1 minus 6, which is -5 over -5. Two negatives cancel, and I get 5 over 5, which is 1. Which means, if I do my slope left to right, I get a slope of 1. If I do it right to left, I get a slope of 1. Slope is a constant. It does not change. Once you know the slope of your line, you know it for every point on the line. It does not matter which 2 points you pick, and it does not matter if you do them left to right or right to left. As long as you do the math correctly, you'll always get the same slope, which is a good thing. If everybody got a different slope, then it wouldn't really mean anything. Now, we said, as far as kind of interesting lines go, horizontal lines have a slope of 0. Does that make sense? Well, if the slope is changed, yeah, it does, because that thing's not changing. It's not going up or down. But to test it, pick 2 points. Say this is the point 0, 5, and we'll say this is the point 5, 5. If I wanted to find the slope, I would do change in y, 5 minus 5, over change in x, 5 minus 0, which is 0 over 5, which is 0, which is exactly what we thought it should be. We get a slope of 0 because it's not changing. One other line, a vertical line. What is the slope of a vertical line? Well, if we want to find it, pick 2 points. I'll say this is the point 5, 0, and this is the point 5, 2. The slope is change in y, which is 2 minus 0, over change in x, which is 5 minus 5. I get 2 over 0, and we know I can't have 0 in the denominator of a fraction, so that's undefined. Which means when dealing with our lines, we can have a positive slope if the line is slanted upwards, left to right. I can have a negative slope if it's slanted down, left to right. If it's horizontal, I get 0 slope. And then in the rare case when it's vertical, I get undefined slope. We are going to do more with this and look at equations of lines, but at this point, this video is probably too long, so I'm going to make another one and go over equations of lines and things like that.